Honors Algebra 2, Chapter 13, Section 5. We're going to look at law of sines today, law of cosines in 13.6. They kind of go hand in hand. They're how to solve for all triangles. It can be acute, right, or obtuse. And so here is the law of sines. Law of sines are just ratios, equivalent ratios of the sine of an angle and the side opposite. All of those ratios are actually equivalent. And so we can set them up as proportions and solve for the unknowns. It doesn't matter if we write in with our side length on the top or the sine of our angle on the numerator. Either way it would work as long as we're consistent within our proportion. So another thing is how we label our triangles. Our triangles are from geometry, angle, angle, side, or angle, side, angle. These are two of the first cases we'll talk about. So in this example, the given information, we have a side, then we have an angle, and then we have the next angle. So that's side, angle, angle. Angle, side, angle will be similar to you're given an angle, the side between, and then the next angle. Both of these are given two of the three angles. So we can actually solve for the third angle quickly because 180 degrees is the three angles added up. And so we add these two together and we get 132. We can subtract that from 180. So then this one has to be 48. 40 degrees. And so now we can write our law of sines out. We can say like the sine of a given angle, 25, over the side opposite 15 equals the sine of another angle we know, 107, divided by the side opposite c, and we can cross multiply to solve. So write out your cross product. 15 times the sine of 107 equals c times the sine of 25, and then divide both sides by the sine of 25 to isolate c. Now try plugging this in to make sure you get the correct value or the same value I get for C. We should find a value of 33.94 is length C. We can repeat that same process again. We can write another ratio, sine of 25 over 15. These are given information for us, which are nice because these are whole numbers, equals sine of 48 over the side opposite A. And then we can again cross multiply to solve that. So 15 times the sine of 48 equals A times the sine of 25. Then divide both sides by the sine of 25. So if we plug that in, we get 26.38. And so then we can solve. That's solving for the triangle, finding all the missing portions of that triangle. So this one, sides have angle, we're given an angle, and then the next two sides. We draw this. I'm very careful with this one, the side angle one. I always put the side I know and the angle I know in these two positions. The angle I know right here, and the side opposite will be 20 here. I don't care what they're labeled, A, B, or C, but if I know the angle and the side opposite, I'll just put it in those two spots. Then if I label this B, the side opposite is 11, and then C, and then C. And so we can go through our law of sines to solve here. Sine of 115 over 20 equals the sine of B over 11. We have to solve for angle B first because we know nothing about angle C or side C. So we can find the second angle, which allows us to find the third angle just using the sum of triangles angles is 180. And then we can use law of sines to find the side C. So let's cross multiply here. 20 times the sine B equals 11 times the sine of 115. And divide by 20. And then to find B, we are going to do the inverse sine of that quantity, 11 times sine 115 all over 20. So you plug this in, try to keep the decimal Don't round it at all. You should find a value for B that's 29.9 degrees. So now we can add that to 115 and then subtract that from 180, and you find a value of 35.1 for angle C. And now we can write another ratio or proportion. The sine of 35.1 over C equals the sine of 115 over 20. I'm using the 115 and not the 29.9 because that's an approximate, a rounded decimal. I'd rather use the exact 115. And again, I can cross multiply here, so the 20 times sine of 35.1 divided by the sine of 115. We find that C is 12.69. And so these would be the measures to solve for this triangle. But this triangle is a little tricky. This example in itself was not bad. And the reason why I know that is because this angle right here is actually obtuse, and 20 is a larger side length than 11. So I know the shape I'm really dealing with. I didn't draw it in that situation on purpose. Is more like this, where this is 20 and this is 115. So I know there's only one option for this triangle because that length 20 is so long. There are other times when we have a side-side angle situation where we can have 0 triangles, or we could actually have 2 triangles that still work with the given information. And so what we need to be able to do is find this information right here, which is called the altitude or the height of the triangle. Now it depends on where you want to draw, but for this triangle we always draw it from the angle we do not know to the side we do not know. The 2 missing segments from the given information is where I draw the altitude or height. We solve that by using SOHCAHTOA. Just this right triangle right here. So 115, h is the opposite, 11 is the hypotenuse. So I can solve it by doing the sine of 115 is equal to the opposite h over 11. And if I multiply 11 times the sine of 115, I get 9h is 9.97. And so we're going to use that number to help us know if we have 0, 1, or 2 triangles. The different possibilities are in this chart here. So this is called the ambiguous case. It's 2 possibilities. First, the given angle, is it obtuse or is it acute? If it's obtuse, we only have 2 possible situations. If the side opposite that given angle, which we just said is obtuse, is really small, it's actually smaller than B, then it's no triangle. The other option is if A is larger than B, that's the situation we just had, an obtuse angle A, and the side A is larger than B, and we get 1 triangle. The more difficult ones is when they give you an acute angle A. We have a few options here. If A again is too small, if it's actually smaller than H, the height, we get no triangle. If A is equal to H, we get 1 triangle, and it's actually a right triangle. If A is bigger than B, we get 1 triangle. And then the difficult one, when A lies between when the measure of A is between H and B, then it can lie or be drawn between H and B. And that gives us 2 triangles. The 2 triangles in this drawing are this green one, actually, going to be the acute one right here that's green, or you can have another one which creates an obtuse angle right here. So the green and the orange are the 2 possible triangles with the given information that both work. So here's an example. We have an angle side to side. So if I draw that out, the angle I know here and the side opposite here. other given piece of information like to put here. Then this would be on missing side B, or missing angle B, missing angle C, and missing side C. So first thing I want to do is find the height. So this triangle here, here's our angle. H is the opposite, 5 is the hypotenuse. So sine of 51 equals h over 5. So if I multiply both sides by 5, I find that h is 3.89. So since 3.5, this segment right here, 3.5, is smaller than h, 3.5 is less than 3.89. So that side is less than h. We get no triangle. And that's this scenario right here. So we have these possibilities which become quite difficult to be able to first assess and then be able to solve. The last situation is how to find the area of a triangle. And there's 3 possibilities here. For all 3 of these, you're given some angle and the sides adjacent to that angle. So you look at the formula, we're given a side, another side, and the angle between. A side A, side C, and the angle between B. So that's how these formulas are written. So an example here for the area in Florida, we can write this as 1/2 times the side 223 times the side 125 times the sine of the angle between, which is 54.2. And then you can see evaluate it. Just plug in chode. We find an area of 11,304.2 square miles. And so that's how you can find area of a triangle given 2 sides and an angle between. So we'll do some more of the ambiguous keys tomorrow in class, but we're going to call it good for the night.